CroppMetcalfe is the one with 5 stars.
Hello, I'm Orrin, the residential service team lead here at CroppMetcalfe. What we're going to be going over today is combustion analysis. We're going to take a look at the tool and the process necessary to complete a combustion analysis. So, let's get started. Let's take a look at the tool we'll be using. Today, we have the FireRite Inside Plus made by Bacharach. This particular model comes with the hard plastic casing. Inside the case, you'll find the combustion analyzer, infrared printer, spare filters. Back behind this cover here, you'll find the test probe that has a K-type thermocouple and a moisture trap. Let's get our analyzer set up and ready to go. Now, if you don't have this particular model, it's okay. It'll be a variation on a theme. I would recommend looking at the manufacturer's instructions for proper setup, but it should be similar. At the base of this unit, we have 3 ports, a negative pressure, positive pressure, and a gas port, along with 2 thermocouple probes. We'll have a T-stack and a T-air. We'll only be using a few of these ports. The positive pressure port, the gas pressure, and the T-stack for the K-type thermocouple. So let's get our test probe. Looking at this probe, we have 3 wires off of it. The K-type thermocouple, which again is going to go into the T-stack. We're going to use the positive pressure port, which is the smaller one, and the gas port, which is the larger. Now that we're all plugged in, we're ready to go outside and calibrate to fresh air. Once you're outside, hit the power button. After the 60-second warm-up period, your screen will then appear. You can then press the run/hold button and return inside and take an ambient CO reading. Okay, now that we're back inside with a properly calibrated combustion analyzer, we're going to take a CO reading of the ambient airspace. We're going to press the run/hold button, get everything going, let our probe sample the air. Now, this is normally going to be in the utility room or wherever the furnace is located. It looks like we are at 0 parts per million, so we're going to go ahead and pause that, record that reading, and get ready to test our equipment. To get our equipment ready to test, we have to go to the Infinity control and put our system into test mode. We're going to hit the touchscreen pad on the Infinity control to bring up our menu, hit our menu key, scroll down to service, press and hold service for 10 seconds until the icon turns green. Scroll down to checkout, go to gas furnace. We're going to be testing this unit in high fire mode only and turning it on. Now, let's go back to our equipment. Okay, now that our unit is in high heat mode, it's been running that way for about 10 to 15 minutes, we're ready to test. First, we want to make sure that everything is sealed up here. Make sure the combustion door is on and the unit is pulling combustion air from the outdoor source or whatever the source is that is getting its air from. We're going to remove the test plug. Insert your probe into the test port. Put your meter into run. Paying special attention to the condensate trap here to make sure that the arrow is pointing up and that your meter is elevated above that. This unit has a handy little magnet on the back of it that allows you to work hands-free. So we're going to let that run till the readings start to balance off. I'm looking at my CO reading. And once that stops moving, we're going to pause it and then check the readings. So it looks like everything has come to a pretty good standstill here. We're going to press hold. We're going to arrow over to bring up the QR reader. We're going to open up the Baccarat mobile app. And we're going to scan a new report. That's scanning the QR code on the device. And it pulls up our report. Once we're all done, we'll review the report to see if we need to make any adjustments on the furnace. We're going to remove our test probe, reinstall our plug, and allow our meter to zero out in the fresh air space. This will preserve the lifespan of your sensors, and it will allow the meter to recalibrate itself to zero. Once your meter is reached zero, you can then feel free to turn it off. Press and hold the power button, and it will initiate the shutdown protocol. Before putting your meter back in its casing, check the condensate trap. Make sure that you don't have any moisture floating around in it, or else the next operation will be compromised. If it's all nice and dry, remove your probe connections and reinstall it in the casing. Okay, let's review our report. Starting from the O2 percentage, that's going to be our level of oxygen. The level of oxygen is a key determinant of both safety and efficiency of the appliance. The average level of oxygen is going to be between 5 to 9%. If we look on our report, you see that it's 7.8, which is within our expected guidelines. We'll move to the CO. The CO is our carbon monoxide level, and that's going to show up in parts per million. The carbon monoxide level is typically going to be below 100 parts per million, which is deemed to be acceptable. Anything over 100 parts per million, you want to check the system for possible service conditions. Next is going to be the efficiency percentage, and that's the gross efficiency of the combustion at that moment. And it's not going to be confused with the annual fuel utilization percentage, which on a condensing furnace like the one we tested, it's going to be pretty close to the same. If we look on the rating on that, which is 95.6%, it's really close to the actual tested rating of 95.1%. Let's move on to the CO2 percentage. The CO2 percentage is our level of carbon dioxide. The level of carbon dioxide is an indication of efficiency in the combustion process. The highest permissible carbon dioxide level is going to be 11.8% for natural gas. So we are well within range at 7.4%. Next column is going to be our T-stack temperature. Our T-stack temperature is the temperature of our flue gas measured at the flue gas hotspot, which is the point in the stack where the CO2 levels are at their highest and the O2 levels are at their lowest. This is typically in the center of the stack. Let's move on to our T-air. That measurement is our primary air or our ambient air. The furnace that we're using is pulling its combustion air from the outdoors, which gives us a temperature of 77.4 degrees from the outdoors.
There is no average on this. It's going to be whatever it is in your area at the time you're testing. Let's move to our next category, which is EA, and that's going to show up in a percentage. Your EA is your measurement of excess air. The excess air is regarded as the most important measurement that your analyzer has in respect to the efficiency of the unit. The excess air should typically fall between 25 and 75%, but always follow the published guidelines from your manufacturer. High levels of excess air are typically seen with an underfired appliance, and low levels of excess air are typically seen on an appliance that is overfired or has insufficient primary air. You want to verify that the venting system is properly installed and is free from any blockage. The appliance is going to be fired within 2% of the rated nameplate data. So let's move on to the COO. The COO is the carbon monoxide content reference to an oxygen percentage. The oxygen percentage referenced here is going to be 0. So it is the measurement of carbon monoxide that is free of oxygen, which is going to be higher than your CO percentage. Our typical COO reading is going to read typically 2 times higher than the CO levels, but maximum level is going to be at 400 parts per million. We'll move on to the pressure. The pressure in the stack, which is going to be at a negative rating, even though it says positive here. Our typical readings on our stack are going to be between minus 0.02 and minus 0.09, depending on the type of equipment and efficiency that you have. That is how to interpret your combustion analysis report. If you have any questions, please feel free to contact your team lead or manager.